right, hi everybody. Okay, so today's lesson is we're learning how to calculate this thing as percent yield. So before we learn how to calculate that, let's kind of talk about a few definitions that play a big role in what it is. So first off, the word yield refers to the products of a reaction. So if you want to just remind yourself that when we have a chemical equation, the products refer to the things that are on the right side of the arrow. They're the things that are being made. And then these are classified as the reactants. So the reactants yield the products, they turn into them. So yield is primarily, or it only is talking about the products. Relating it back to cooking, kind of like what we did at the beginning with S'mores Lab, yield refers to how much the recipe says you should be able to make, right? So when you read a recipe, it tells you you should be able to make 3 dozen cookies, or whatever it is, for example, okay? So yield is how much product will be made, and every stoichiometry problem we've actually already done that deals with finding a product is finding the yield. Oops. Here we go. Okay, so now there's two different types of yield. We have what is known as the theoretical yield. The theoretical yield is the calculated amount of product that you should be able to get based on what you have, okay? The thing is, it's theoretical because you actually haven't performed the experiment yet. You're just saying based off our numbers. So, for example, going back to the analogy of s'mores, right, I was thinking about what other activities I can do at my house with my toddler during this little break we have. And I was like, hey, we have some leftover s'more stuff. I'll take some s'mores home and we'll roast them on our stove. So if you're looking for an activity, find a bag of marshmallows and you cook s'mores with your family. So if I were to take home 3 chocolate bars, 3 marshmallows, and a box of graham crackers, okay, theoretically, I should be able to make 3 s'mores, right? Because I have plenty of graham crackers, and then the chocolate and the marshmallows make me 3 s'mores, right? But once again, it's theoretical because I haven't actually gone home yet and tried to make the s'mores. It's taking into account that I don't make any mistakes and that everything works out like it should. Okay, once again, the theoretical yield is based on math. So the stoichiometry tells us how much we should get, or my recipe and my ingredients tell me how much I should be able to make. What you actually end up with is the actual yield. And here's why there's a difference between the two. Is the actual yield is based on the lab data. It takes into account the errors that might happen, right? For example, for me, there's a good chance when I take home these ingredients, put these on my table, that my toddler will probably just start eating the marshmallows before we even get a chance to make the s'mores. And so in the end, we may not be able to make all 3 s'mores. First off, you need to recognize that the actual yield must be less than what the theoretical tells you because things can't be created or destroyed, right? You can't end up with more than what you started with, right? If this is all I brought home, I can't have 5 s'mores all of a sudden, right? That doesn't make any sense. Okay, and then these are the 2 factors that can kind of affect your actual yield. So one is lab errors, and this is the main one, and when we get back together, we'll be doing the lab where we'll calculate a theoretical amount of silver that we'll be able to make. Then we'll go and make some silver in the lab and see what we actually get, and all these things can go wrong, right? You can spill, overflow, transfers, burning, unintended reactions because the glassware was dirty, and so many others, right? There's a lot of mistakes that can happen in the lab. The other thing that can make your actual yields have problems is the reaction itself. Some reactions are just really hard to do, and the molecules don't bond easily like you want them to, and so you can't get that 100% yield that you're hoping for. Okay, stubborn molecules. So percent yield is a way in which we can compare what we actually got to what we should have got to kind of gauge the success of an experiment. It's just the same as a percentage on the test, right? When you calculate your percent on a test, you say, okay, this is how many I actually got right compared to how many I could have gotten right, and it tells you how well you did, right? Same idea here. So the equation for percent yield is the actual yield over the theoretical yield. Once again, remembering that the actual comes from lab data. So in terms of like our worksheet and our quiz we'll take on this unit, this is going to be something that's given to you because you can't calculate that. You have to go and do a lab. But then this is what you calculate using stoichiometry. So that three-step process that we learned last time helps us find the theoretical yield. So if you are still having problems with three-step stoichiometry, please reach out because it plays a big role in knowing this I can as well. So yeah, if you're stuck here, let me help you get here because then it's not too bad to throw the two pieces together. All right, let's take a look at a problem. So once again, measured in the lab, calculated on paper. Okay, so the problem here says when 45.8 grams of potassium carbonate react with excess HCl, hydrochloric acid, 46.3 grams of potassium chloride are formed. Calculate the theoretical and the percent yield of KCl. Now, first off, recognize here that percent yield is based off the product, because remember, yield refers to product. Okay, so the first thing we need to identify is, okay, from the problem that's given, what do I know about my KCl? And it tells me that 46.3 grams of KCl are formed. Which means this is my actual yield. That's how much was made in the experiment. So what we want to find now is how much of this could be made, which is the theoretical yield, based off what I put in. So what I put into the reaction was 45.8 grams of potassium carbonate. So take that as your starting point to help you figure out the theoretical yield of KCl. Okay, so we're going from grams of potassium carbonate, and we want to convert it into grams of potassium chloride. So if you need to use your map, and you'll be able to use it on the quiz, so don't be afraid to use it. This is a grams to grams conversion, which means the first step, because it's always the first step, is to change this from grams of KCO3, K2CO3 into, change the colors again here, moles of K2CO3. Okay? Then we can go from moles of potassium carbonate, and we can change it into moles of KCl. From there, we can go from moles of KCl and change it into grams of KCl. Okay, so we got grams to moles, moles to moles, and then moles back into grams. Okay, let's plug in our relationships. So a gram to mole relationship is the molar mass of the substance. So when I added those all up, I got 138.21 for every 1 K2CO3. The mole to mole relationship comes from the balanced equation. So 1 K2CO3 for every 2 moles of KCl. Then mole to gram relationship is molar mass once again, which I got as 74.5 for every 1. Plug that into our calculator and we get 0.38 grams of KCl. And this right here is my theoretical. That's how much I should be able to make if I didn't lose any of this and nothing went wrong in the lab process. Now, it's a good thing to recognize here that this is bigger than the actual, which it should always be. If it's not, you've probably done something wrong and we need to backtrack a second. Okay? All right, so now to calculate the percent yield, we simply take the actual over the theoretical and then times it by 100. Now once again, notice that the two numbers that I'm comparing are both KCl. Okay, a common mistake is to be putting different substances over top of each other, but that's not the percent yield. It should both be yield over top of one another. Okay? Plug that into our calculator and you get 93.76%. So what that answer tells us is we did a pretty good job in the lab. We got 93% of what we should have been able to get. So, and that is how you find percent yield. Okay, now some of the problems we'll do will just give you these two numbers straight up. You just have to divide them. Others you'll have to find the theoretical first and then set up your fraction. Okay? So your homework assignment is the percent yield one in your assignment packet. Try those problems out. After you have tried all of them, you can go onto Canvas to plug them in to see if you're doing it right. If you get the answer wrong, we want to figure out what we're doing wrong. So if you can't figure out what you did wrong, I am going to post a help page that will show you the work for some of the problems. So you can use that to kind of help you figure out what you did wrong. Or as always, please reach out if you don't quite understand what's going wrong. Okay? I'm here to help you guys, just a little bit from a distance, so don't be afraid to reach out. Pretty much where we're going from here is next week is taking the quiz. We're going to leave the quiz open from Tuesday till Friday, and you'll actually have 2 attempts at taking it. Or I guess there's 2 different versions you can take, and whichever score is higher. You don't have to take it twice. So if you take it once and do great, you're done. You don't have to take it again. But if you take it once, you can look over it, ask me questions, so on and so forth, and then take it again the second time. Once again, big picture here, guys, is I just want to see that you understand it. Okay, we can deal with points and things later if you're worried about that. Don't stress about the points right now. We'll fix grades and stuff, but what I want to see is where we're at, and if we don't understand it, let me help you so we can get there, so that we can keep learning through this fun time together. Okay, good luck, guys. See you soon. Bye.